Example 6. Find the coordinates of the points where the tangent to y equals x cubed plus x plus 2 at the point of contact 1, 4 meets the curve again. Okay, so what are we thinking about here? What are we looking at? You need to try to analyze what's happening. We've got this function. It's a cubic function, so it has those two twists in it. So something like this. Point of contact is 1, 4. And where does that meet the curve again? So we'll go to our TI Nspire, and we can graph this function. Oh, we need to go home. We need to graph and type in our function, which was x to the power of 3. Scroll over, plus x plus 2. Okay, double check, see if I got that right. X cubed plus x plus 2. Yes. And enter. Okay, there's that graph. All right, our question is asking, we're looking at the point 1, 4. Okay, so let's find that point on our graph. We can pick out the point 1, 4 on here. There's 1, 2, 3, 4. Point 1, 4. All right, that's what the graph looks like. Okay, so find the coordinates of the point where the tangent meets the curve again. So we're going to need to know the equation of that tangent. So let's draw this a little more what it actually looks like. 1, 4 was somewhere up here. So we're looking for where that tangent line meets the graph again. So something like that. So we need the equation of the tangent line. First thing we'll need is the derivative. That will be 3x squared plus 1. So the gradient of the tangent when x equals 1 from our point of contact is 3 times 1 squared plus 1, so 4. So the slope is 4. This is a straight line, so y equals mx plus b. Slope is 4, so 4x plus b. The point of contact is 1, 4, so substitute that in to calculate the y-intercept. And the y-intercept is 0. Therefore, the equation of the tangent is y equals 4x. All right, so where does that meet the curve again? Now, we could try to do this algebraically. Points of intersection. We know we can set those two equations equal to each other. It's going to be the point or points that satisfy those equations when they're equal to each other. So x cubed plus x plus 2 equals 4x. Okay, so x cubed subtract 3x plus 2 equals 0, but we don't know how to factor this guy. So let's use our graphing calculator. And we've got this graph. We also have this graph. And where do those intersect? So we'll graph a second graph, tab, y equals 4x, enter. And there we have it. And we've got another point of intersection down here. So we need to zoom out a little bit. So menu, window, zoom out. Okay, that's good. We can now see our point of intersection. There's only one other than the 1, 4. Now our 1, 4 is in the wrong place. We need to change it. Okay, but 1, 4 is here. And our other point of intersection is down here. We need to determine what that is. We can do it exactly with the calculator, so menu, analyze graph, intersection. It's asking here for a lower bound, so we need to move that lower bound over. Lower bound, this dotted line just needs to be on the left-hand side where that point of intersection is, somewhere on the left-hand side. Okay, that's good. Enter. Upper bound, now we need to move the dotted line to the right of the point of intersection. Enter, and it tells us the point of intersection right here. There's the numbers, let's grab it so we can see it. -2, -8. The question asked us, find the coordinates of the pointer points where the tangent to that function at 1, 4 meets the curve again. So the answer is -2, -8.